Okay, in this video we're going to take a look at, this is video 5.1b, we're going to take a look at how factoring can help you verify an identity. These are two problems from your book. The first problem is, they're both from section 5.1. The first problem is question number 37 and the next one is question number 51. So we're going to take a look at this identity and we're going to verify it. So remember, we want to get the left side to equal the right side. First thing I notice is the left is more complicated, so I'm going to start with the left side. And I'm going to think about how I can simplify that to get the right side. So I see the right side has absolutely no fractions in it. It's just very simple sin x minus cosine x. So somehow I need to cancel out the bottom or work it so that the bottom turns into 1. And that is going to be my ultimate goal. So I mentioned at the beginning of this video that it's about factoring. The top can be factored. The top is like a difference of two squares. We can think of this as an a squared minus a b squared. That easily factors into a minus b times a plus b. This is the difference of two squares, something you'll want to get really familiar with. So I'm going to factor this guy, the top, into sine of x minus cosine of x times sine of x plus cosine of x. Another reason why this is going to be super nice is because take a look at your denominator. Your denominator is one of your factors of your numerator. So that's the other thing you want to look for. Is the bottom potentially a factor of the top, or vice versa, depending on where your more complicated piece is? In this case, it was the top of the fraction. So in the bottom, it will cancel nicely with the second factor in the top. I'm left with 1 in the bottom. When you cancel fractions, you're left with 1. Let's see, so my result now is sine of x minus cosine of x. And I am left where I was supposed to be going. And I'm done verifying this identity. So sometimes it can be as easy as that if you see what to factor and how to factor. But always take a look at, think about why you're factoring. You're factoring so you can cancel from top and bottom. So if something's in the bottom and you think it might appear in the top or vice versa, definitely try factoring and see if you can work that out. This next one's going to be similar, but it's a little bit different because it'll take a couple more steps. So we have cosine to the fourth t minus sine to the fourth t. We're going to start with that side and write it down properly here. Cosine to the fourth t minus sine to the fourth t. Once again, this is a difference of two squares. It happens to be a to the fourth, but a to the fourth is just a squared times a squared. It's a problem, it's a number squared, or in this case a variable squared, or a function squared. And this is b to the fourth, which can be written as a perfect square as b squared times b squared. So we can factor these differences of two squares as a squared minus b squared times a squared plus b squared. It's essentially the square root of the original a to the fourth, b to the fourth. Take a look at this one right here and make sure that you agree that that in fact will multiply out to the 1 up here. And if you see that, then that's definitely something that is going to be interesting to pop out at you on occasion. Whenever you see the difference of two squares, know that a power of 6 would not be a perfect square because nothing times itself would give you 6 for a power of 6. So just be careful and don't overgeneralize. So this is going to factor into cosine squared of t minus sine squared of t and cosine squared of t plus sine squared of t. So one of the major reasons I did this is because, number one, I noticed it. I also don't know much about cosine and sine to the fourth power, but I know a lot about cosine and sine to the second power. For instance, this right here, you'll use the Pythagorean identity and change that to 1. So we're left with cosine squared t minus sine squared t. So we're getting closer to our goal. I look back at my goal so I don't forget where I'm headed, and I see, ooh, I have a 1 minus sine t, sine squared of t, but I need 2 of them. So how can I introduce another sine squared? Well, that's where cosine squared comes in, because I don't want cosine squared in my answer. So I go back to my Pythagorean identity, and I know cosine squared t is equal to 1 minus sine squared t by Pythagorean identity. So I'm going to replace that with 1 minus sine squared of t. I still have the minus sine squared of t from before, from up here. And then I start to see my result. I have 2 sine squares of t. And I've arrived at my final conclusion. The left is equal to the right. So that's how you can use factoring to help you further. It just takes practice to recognize these quickly. Otherwise, just make sure you have the most important special products like the difference of 2 squares and perfect squares that were listed in class on the whiteboard. Make sure you have those written down somewhere so you can use them quickly. Bring in your questions tomorrow, and hopefully that helps get you more strategies on how to solve some of those verifying identities problems.